So now we're going to use recursion to solve a factorial. And factorial is something that is used to teach recursion in pretty much any course that teaches recursion. And if you've never seen a factorial before, it looks like this. This is 4 factorial. And 4 factorial is 4 times 3 times 2 times 1. So I'm going to shrink this down like this, and let's walk through why this is a perfect thing to use to teach recursion. So 3 times 2 times 1 would be equal to 3 factorial. So you could say that 4 factorial is equal to 4 times 3 factorial. And you could say that 3 factorial is equal to 3 times 2 factorial, and 2 factorial is equal to 2 times 1 factorial, and 1 factorial, well, this is our base case, so this one's going to be different. 1 factorial is just going to be 1. A couple of videos ago, we talked about a couple of things that you need to have in a recursive function. The first is that you need to be doing the same thing over and over. And you can see that this process is the same all the way down. The other thing is that the problem needs to be getting smaller until you finally get to a base case. So this is perfect. So I'm going to shrink this down. And what I'm going to do is I'm just going to bring in the entire function, and then we'll walk through it. So this is our recursive function for factorial. We're going to pass this a number in. In this case, we're going to pass it the number 4. Then we're going to check to see if n is equal to 1. When we get to the point where n is 1, we're going to return 1. If n is not equal to 1, we'll come down to this line here, where we return n times factorial of n minus 1. So this is where the function calls itself. So in this first iteration, it would look like this. We're going to return n, which is 4, times factorial of n minus 1. N minus 1 would be 3. So let's move this function up to the corner like this, and we'll walk through this. So first we have factorial of n. N is equal to 4 to begin with. And we'll say, is n equal to 1? Well, obviously it's equal to 4, so it's not 1. So we will return n times factorial of n minus 1. So we can do this, and we'll populate that with 4 and 3. So now we're calling the function with n being equal to 3. So when we run our if, is n equal to 1? It is not. So that causes us to run this line here. And this is going to be 3 and 2 this time. So we're running factorial on 2. So now our if statement is n equal to 1. It's not. So we have to run this line again. And now we're going to use 2 and 1. So we're running factorial on 1. So now when we say if n equals 1, it is going to be true. And we're going to return 1. That is this 1 here. So now let's just look at these lines here. Let's spread these out. And when we return the 1, we're returning the 1 to this function call here. And then we're going to return 2 times factorial 1 to this function call, and so on up the line until we return the answer to this line here. So let's walk through what this is going to look like. So when we return 1 there, we're returning 2 times 1, which equals 2, up to here. Now we're going to return 3 times 2, which equals 6, up to here. Now we're going to return 4 times 6, which equals 24, up to here. And factorial of 4 equals 24. So now let's look at this a different way. Let's use the GIF boxes that we used a couple of videos ago. So we start out with this being factorial of 4. then 3, and 2, and 1. And in the gift box video, we had a ball when we reached our base case, but now this is going to be a 1. And then 1 gets returned to this function call. And then we have 2 times 1 is 2, gets returned to this function call. 3 times 2 is 6, like that. And then finally we get to the 24. And now let's look at this yet another way with our call stack. We start out with factorial 4. That goes onto the call stack first. Then we have factorial 3 gets pushed onto the call stack. And then 2 gets pushed onto the call stack. And then 1 gets pushed onto the call stack like this. And it's only that last instance of the factorial function that can run because it's at the top of the call stack. So remove that, and then we can calculate the next one like this, and so on until we get to here, and then we return the 24. So now let's go look at this in VS Code. So there is our factorial function there, and then we'll call it here factorial 4 and print out the result. And just like we did in the last video, we're going to come up here and open this run and debug side window like that. And then over here, we're going to click on the 3 dots. And we're going to choose the debug console. And next to this line, we're going to click the red dot, highlight that to create a breakpoint. Up here for run and debug, we want Python current file to be here. And if it's not, do the little drop-down menu, make sure that's selected. And we'll click on the green play button. And now we can walk through this step by step. So now when I click on the step into, it's going to run factorial, the factorial function, with the value of 4, and that gets pushed onto the call stack. It's going to check to see if n is equal to 1, and obviously it is not, so it's going to come down here, and when I click on this again, it's going to push factorial onto the call stack again, this time with the number 3. So notice that both functions on the call stack are named factorial. And that's why I did the call stack video I did in the last video. It's easier to keep track of this and kind of see what's happening when the items on the call stack are called function 1, function 2, function 3. In a recursive function, it's just going to be called factorial because it's calling itself. But these are distinct instances of factorial. So I'm going to come up here and we'll step into this again. The if statement is going to be false because n is not equal to 1. We'll come down here. And now we're going to get another factorial pushed onto the call stack over here. You can see we have 3 of them now. This latest one is with the number 2. N is still not equal to 1, so we're going to come down here again, and now it's going to get pushed onto the call stack with the number 1. Now we have 4 factorials on the call stack, but this time n is equal to 1, so we come down to the return 1 here. And when it returns that 1, it's going to pop one of those factorials off of the call stack. So I'm going to click on this, and you can see that we only have 3 factorial functions on the call stack now. And as I showed before in the animations, it's returning it here. It is returning it to where this was called with the number 2. So when I click on this, that's going to get popped from the call stack. And this is going to be with the number 3 and with the number 4. This will be the final one that gets popped off the call stack. And it's going to return that value to here. And so for this last one, I'm going to move over from the step into a couple of buttons over to where it says continue. And when you click on this, it'll just run the rest of the code. And I'm going to do this because there's a message that will pop up otherwise. So I'm going to click on this, and you can see that we have the number 24 that's been returned. And that is our recursive function for factorial.